Now, this normal distribution has certain characteristics. They have certain characteristics, okay? So we are going to look at the characteristics of this normal distribution, and we make use of these characteristics together with the parameter to do calculations. Calculate the probability that they will lie between 42 and 48. What is the probability of a student, the marks is between 50 and 60 marks? We can calculate the probability if we know the mean and the variance. We can calculate the probability of a particular student getting marks between two numbers. Now, why between two numbers? Because the probability of getting a particular number is zero in a normal distribution. Because it's a continuous distribution, the probability of getting a particular number is zero. Whereas this binomial distribution, the probability of getting a number is, yes, you can calculate the probability of x getting a number. But in normal distribution, you cannot get the probability of x equal to 42, cannot get. But you can get the probability of x between 42 and 45, can. That is the difference between normal distribution and binomial distribution. It has to be between two numbers. You cannot take a specific number for normal distribution. Okay, right. So if you have no questions, you have no doubt about anything, then I'm going to explain to you one by one the characteristics of a normal distribution. No question? Okay, first one. A binomial distribution, if the value of n is large, then it approaches a normal distribution. So what they are saying here is that while you are doing a binomial distribution, if you do the binomial distribution many times, so the n become very big, right? Or not the sample, sorry, you take a very big sample and you do it many times, then this binomial distribution, it can become a normal distribution. How big is normal? How big the binomial, then it will become a normal. The condition is like this. If the number and the probability multiply together, if it is bigger than 10, then you can translate this binomial distribution to a normal distribution. And this is not the only condition. The other condition is the n times the q must also be bigger than 10. Both of them together. You cannot just take one, oh, np greater than 10. It can be translated as a normal distribution. No, you have to check also the value of nq. If nq is also bigger than 10, then you can use a normal distribution to approximate the binomial distribution. That is the first characteristic. The second characteristic that you need to know is that this normal distribution, the variable here is a continuous random variable, right? It's a continuous random variable. Unlike the binomial distribution, the x, they are discrete. They are one number, one number, one number, one number like. Whereas in a normal distribution, it is not one number, one number. It is from this number to another number, right? The number can be any number in between two whole numbers. But if you take binomial distribution, it's either 1, x equal to 1, or x equal to 2. It cannot be x equal to 1.5, x equals to 2.5, or x equals to 1.5. Cannot like that. Normal distribution, it can be anything between 1 and 2. It can be 1.5, 1.25, 1 and 3 over 5. It can be anything in between. And for this normal distribution, the mean, the median, the mode, they have the same value, right? Meaning to say, if let's say the mean is 42 just now, 42 marks. most of the people will also get 42 marks. That means the mode is also 45. Then if the mean is 42 marks, then the median is also 42 marks. The middle number is also 42. So this is another characteristic of a normal distribution. Okay. Then another characteristic is that for a normal distribution, you can divide the distribution into half along this line, the center line. And the center line is the mean, is the mean. And the shape of this curve on this side and the shape of the curve on the other side, they are symmetrical, 100% symmetrical. If they are not symmetrical, then you cannot calculate the probability. Right? So it means that 50%, if you look at here, it means 50% of the student will have marks bigger than the average. Another 50% of the student, they will have marks less than the average. So it is the mean is the dividing point, this half and the bottom half. Normally, we don't call the top half and the bottom half. In a normal distribution, this part we call it the upper tail, T-A-I-L, tail, ekor atas. So this one, the one this side is called the lower tail. Lower tail means ekor bawah. Is that the correct bahasa term? I don't know. But the English word is called, this side is called the upper tail, this side is called the lower tail. And in your normal distribution table, they only show the half on the right hand side. They only show you the upper tail. What is the bahasa word for upper tail? Anyone knows or not? Have you done this topic in class? Huh?
Don't know, teacher.
Huh?
Hmm?
Don't know.
Yes, teacher. I
This
don't
one,
know what's called in Malay.
don't know. The teacher teach in bahasa or in English?
English.
Oh, sorry. Then in English, then this is called the upper tail. But you don't worry because if you go higher form, you have to learn in English. You cannot learn in bahasa. You go to university, you go to college, you go to form 6, everything will be in English. So you don't have to learn in don't if you don't know the bahasa term, you don't need to worry. Okay, so you call this side, the right hand side, we call it the upper tail. The left hand side, we call it the lower tail. It's not my story, this is real thing, they are actually called the tail. Okay, so the symmetry, okay, symmetry, they will divide it into upper tail and lower tail, right? Okay, the total probability is 1. So that means the probability on this side is 0.5. The probability on the right hand side and is 0.5. Probability on the left hand side also 0.5. Okay. Okay, and they say the probability from the mean taper off equally in both ends. Taper off means they go smoothly down like that. They curve down and become narrower and narrower. That is taper, right? Taper off. And the tapering off here and the tapering off on the left and the right, they are the same. The same. The probability is the same. Okay, right. And the total probability is 1. The total probability. Now, the probability is also the area under the curve. The probability is given by the area under the curve. And here we call it not the frequency, but we call it the probability density function or the probability density. The y-axis is the probability density. The x-axis is the value of the x. And the area under the curve, like what we learned in integration, area under the curve. The area under the curve represents the probability. And the total area under the curve is 1 because the total probability is 1. Okay, now this normal distribution is governed by two parameters. The two parameters, they are mu and sigma. Mu, this is mu. Mu is also the coronavirus variant. Mu, lambda, delta, they are the coronavirus variation. So today they found one mu variant in Labuan, I think. Labuan they found one mu and one delta there. But then our mu and delta here, not the coronavirus. Huh? The mu here means mu. How to spell mu? This one is mu. Eh, mu is like that. M-J-U, mu. Okay, mu is like that. Then this one like the Chinese character, this is called lambda. Lambda, lambda, L-A-M-D-A, lambda, right? Okay, so right, so this is called mu, right? MJU. Now let's say you have two distributions. One, the mu is 42. The other one, the mu is 35. So graphically, it will be like this. It will be like this. So the one with the bigger mu is, the graph is shown on the right hand side. The one with the smaller mu is shown on the left hand side. So this is the difference in the first parameter, the mu, the first parameter here. And the shape, if the sigma, the standard deviation or the variance is the same, the shape will be the same. The shape will be the same. What happened if the mu is the same but the sigma is different? It will be like this. It will be like this. If the mu is the same, let's say both of them 42. So the blue curve, also the mu 42. The red curve, the mu is also 42. Let's say the blue curve is shorter and fatter. They distribute over a wider area. That means the sigma or the standard deviation is bigger. That's why it's shorter and fatter. Now, if the standard deviation is smaller, they are taller and thinner. It's like the pink color here. Okay, so when the sigma 1, sigma 2 is greater than sigma 1, it means that the standard deviation for the second curve is bigger than the standard deviation for the first curve. So the shape will be like this, right? Then the next one is the area under the graph represents the probability, right? So let's say this area here, this area, the shaded area here. Now this shaded area, the purple color here, represents the probability of x between A and B. How you write? You write like this. Probability of x between A and B. Right? You write it this way. Okay? This probability is represented by this area between A and B, right? But then in between